So, now you have a quadrotor consisting of an airframe with motors and propellers and speed controllers being driven by an autopilot to adjust the vehicle attitude, which is constantly being measured by the IMU, and your position is provided by GPS. But then what? How do you execute a mission? Of course, you could just have a human pilot, but this program is all about autonomous flight. So how do you replace the human? Well, you need a brain on board, of course, and the flight computer will be the brain for the vehicle. The flight computer, like this one, is generally responsible for all parts of the mission, including, for example, planning a safe trajectory through obstacles and managing the payload, or position estimation when GPS is flaking out. If the flight computer is the brain, you can think of the autopilot as more like the spinal cord or lizard brainstem of the vehicle, responsible for lower-level processes. And then, the flight computer is responsible for higher-level functions, like deciding what the vehicle should do next, and how it should respond to new information. There are, in fact, multiple levels of control on any autonomous system, and drones are no exception. The way the whole system, the flight computer, autopilot, sensors, and mechanical parts function together is through a series of what are known as control loops. So let's draw this out. First, you have your autopilot, which is getting information about attitude from the IMU. It compares that with the target attitude and sends small adjustments to the motors, which act to change the attitude of the quad, and the cycle continues with the IMU, making a new measurement. So, this is the attitude control loop, where the autopilot is constantly updating the motor thrusts based on sensor data from the IMU. This loop is always running in the background, just like your brainstem keeps your vital organs working without you having to pay attention. On top of that, there's a position control loop. Sometimes it's in the autopilot, but more often it's in the flight computer, where the position control loop is receiving information about the vehicle position from GPS or other sensors and computing a target thrust vector in order to move to the desired position. That thrust vector command is then sent to the autopilot loop, which in turn adjusts the motor thrusts to achieve that new attitude, and the cycle continues with the GPS making new measurements. These loops do not need to be synchronized, and most often they're not. The autopilot loop might be executing at 50 cycles per second, or 50 hertz, while the position loop might only be executing a few times per second. So the way this works is that, for instance, if the mission is to inspect a wind turbine, the flight computer will be responsible for working out how to fly that mission, or in other words, what the vehicle trajectory should look like as a series of positions in space. And the autopilot will be responsible for executing that plan as it gets regular updates from the flight computer on how to adjust the thrust vector to arrive at the desired series of positions. And there you have it. Your quadrotor has a brain.